Y10! Way! You're here! Look at that. Already there and waiting. Outstanding. It's nice to see you, Tiffany. Nice to see you, Laura. Nice to see you, Libby. Nice to see you, Lynn. Oh, you're all here. Isn't that fabulous? Right, I'm going to get straight on with my lesson today. I do seem to be struggling a little bit in terms of my laptop's having slight issues. And it does seem to be a little bit sticky. Can you guys hear me okay? Is everything working? I might change my microphone setting, my camera settings. Let's reduce that down to standard. There we go. That might be a bit better. There we go. Right, I'm going to get straight on with the lesson. So today's lesson, by the way, I've figured out a new trick. So I'm now going to disable my device, my camera. Yes, I do want to disable it. And then I'm going to go back to my StreamYard, and I'm going to do share screen. It's shaky. Oh, nuts. Hide. But there we go. I've disabled it. Hopefully it'll be able to calm itself down in a little bit. But okay, I'm straight in with my lesson today. So what I'm going to do, we need to finish off equations, finish off the equation side of things. And, I'm just going to add that to there like that. There we go. So I'm going to be finishing on, I'm going to be reviewing the equations that I set you guys for homework, which I thought was a very reasonable thing to do. I'm going to review those. And then I'm going to add on the combustion bit, which we haven't quite covered yet. That's what I'm going to do. I'm hoping that my laptop is going to calm itself. I'm going to turn down the problems. It might be a little bit slow today, but we'll do our best. Okay, so first of all, let's review the equations that you guys. So the first thing you had to do here was balance the simple equations and change to word. Okay, so they've given you the equations in full, and they just wanted you to be... I think most people have completed this. I don't know what's going on here. Let's just, I don't know what's going on there. I'm just trying to get my YouTube up so I can see the chat that's going on. View on YouTube, I think that's the one I need. And definitely need to mute it. Cool. Wait, I think that's right. You didn't send them. You didn't post the worksheet, Mr. You didn't post the worksheet. He edited the post. When? Oh, okay. But I asked the other class for it. This morning. Sorry, guys. In that case, what I'll do is that's actually ideal. That's absolutely fine. So you're right. I didn't realize that I'd put it on and I attached it for one class, but not ideal. So what I will do is I'll go through that worksheet with you guys. Next lesson, and let's just focus on combustion equations today. So title is combustion equations. In fact, I'm going to start from scratch from my usual lesson standpoint. So I'm going to go, this is combustion equations. Combustion equations. Number one, no requirements. No, what is needed? Make it easier. What is needed for combustion? That's kind of going over the fire triangle. You did it in year 9, but it's nice to do a little bit of quick revision on that one. Who have I got now? I've got Audrey, I've got Melanie, I've got Zach, I've got Howard Ping, I've got Caitlin. Woo! Guys, we're rocking this. We're smashing it. Yeah. Thanks for coming, guys. It's great to see you. So what is needed, let's put that on, they are needed for combustion. For combustion. Number 2, I need you guys to know complete combustion. I'm just going to put comb versus incomplete combustion. Incomplete combustion. I need you guys to be able to give environmental problems, give environmental problems of combustion products. Combustion products. So those are our 3 learning objectives today. I know that you guys are probably wondering why we're doing these kind of things, especially since we're studying calculations. I totally get why you'd say that. But in reality, because all of these they're all part and parcel of this. Everything comes together in chemistry at one point or another anyway. So it's not a problem that we would be doing it in this fashion and I'm going to be adding these little bits on. It's far better for me to do it. So, okay. So we need to link this very specifically to combustion equations. So, okay. The first thing I'd like to do is I just want to do a bit of recap. Recall on organic. I think that's a good idea. So, first question number 1. So, name the first 4 alkanes, please. Name the first 4 alkanes. You may now pause the video and give your answers. Lol. It's funny. So pause the video and have a go. Okay, so what are our answers for the first 4? I think most people will be able to remember this from E&I. So we've got methane, ethane, propane. Most common one to get wrong is propane. People say pentane, even though they know pentagon's 5. Pent's 5. And butane. After that becomes easy. Pentane, hexane, heptane, octane, nonane, decane, up to 10. But the first 4, you guys have just got to remember them. Yeah, I'm going to put that as a capital. So that's Mary eats prawn butties. I got that from a student of mine a long time ago. There are many different versions of these kind of acronyms to help you remember it. You can make up your own if you wish, but you just need to remember the first 4. Right, so now that you've done the naming of them, be interesting to see how many people of them got everything right. I'm just gonna remove that one. Yeah, I'm just gonna remove that one. Sorry, Tiff. I think you understand why. Okay, so question number 2. Give the formula for the first 4, for 1 to 4 alkanes. So what's the formula for methane, ethane, propane, and butane? You may pause the video now and give your answers. Okay, so once you've unpaused, we've got CH4, then we've got CH3, CH3. By the way, if you prefer C2H6, then we've got CH3, CH2, CH3. This is a structural, by the way, I don't mind though. C3H, double it and add 2, 8. And then the last one, CH3, CH2, CH2, CH3, otherwise known as C4H, double it and add 2, 10. So it's nice. What I'm doing there, folks, is these are the molecular. This is the molecular formula, and this is structural formulae. This is molecular. I'm sure you guys remember all of these things from year 9. Yeah, molecular versus structural. Okay. So now that we're up to there, right now that we've kind of done that reminder of that, I'm tempted to give you one more question. Just going to give you one more. So complete. I'll see if I can make my pen a bit thicker at this point. I'm trying to put my little fan somewhere to cool down my laptop. But question number 3, complete the formula. Complete alkane formulae. C blank H 62. Next, C 18 H blank. complete. Pause the video now and give me your numbers. Right, so we know that the general formula is CnH2n plus 2 from year 9. So the first thing we're going to do is take away the plus 2. Takes me down to 60. Then we're going to divide it by 2. Takes me down to 30. So that is C30. Next one, going in the normal direction now. So I'm going to double it times by 2. That's going to give me 36. Yeah. Plus 2, 38. I think that's right. I don't like doing any maths in my head. I just don't like doing it. Plus 2, yeah, 38. There we go. Take it if you got it right, folks. If you're getting it right, you're doing great. It's good year 9 memory recall. Right, now we need to do combustion. Okay, so title. New title. Sorry, my laptop's being a bit slow at the minute. Oh, it's been really slow. Okay, there we go. So, combustion. Okay, so the first thing I think it's good is just to remind ourselves of the combustion triangle. So the combustion triangle, you guys often saw looking a bit like this. I'm going to see if I can do some artsy skills here. There we go. Oh, this is a terrible combustion triangle. Fire! There we go. Let's give it some real flames. Let's make it flamey. I love a good bit of flamey combustion. Yeah, look at that. Loving it. Flamey combustion. Look at that. Oh, and it's putting the yellow underneath. That's amazing. So we've got combustion, and we're going to need, number 1, we're going to need fuel. We need something to burn. Yeah, and of course, those are all of our alkanes. So this here is our alkanes. We love to burn alkanes, and they are number 1 use of fuels. The next thing we're going to need is we're going to need oxygen. So we need oxygen, O2, and of course, we also need heat. Now, just to say, by the way, heat's an interesting one. Heat really is just to get things started. Yeah, get started. Oh, no, gone Yorkshire. It's to get the fire started. Once fire's started, it produces heat. So why do you need to add heat in the first place? Because you have to break original bonds. That's why. Because we know that pretty much everything burns, except for ionics. Ionics don't burn. Anything that contains carbon or hydrogen will burn. And you've just got to get that. You've got to give it that initial heat, because the initial heat's going to break the original bonds and then allow it to actually bind with the oxygen. That's what's going on there. So heat gets started. So now that we recognize that there's this combustion triangle, what we can now realize is that there's actually 2 different types of combustion. There is complete combustion. Now, complete combustion. And I think I'm actually going to do complete combustion versus incomplete. Now, I'm pretty sure that you guys will have done this in year 9 again already, incomplete combustion. And however, I know that there are some students who haven't done this yet because they weren't here in year 9. So it's nice to do this kind of revision. I think everyone would be able to immediately say which one we're after, because, you've got these 2 types. Well, which one do you think is probably going to be better? And you can do this just simply based on the English word. Yeah. Let's be fair. If a teacher asks you to do something, do you complete it or do you incomplete it? Which one is the one that we're wanting? And we're going to want complete. Everyone in this room knows that. We're after complete. But the question is why? So the first reason why is this produces more energy. This produces, I'm very aware that people are probably going to be taking notes, produces more energy compared to incomplete. More energy, less energy. And of course, why are we burning stuff? Yeah, we're burning stuff because we want energy. We want heat. We want electricity. I'm just squaring that up, by the way. It's bothering me. I've made it too slopey. Incomplete combustion. There we go. And that produces, so we're obviously wanting this guy. More energy. Yeah? Max energy output. Okay, what else is good about complete combustion? Does anybody know any of the other things? Yeah, what else is good? The answer is, with this one, we only get carbon dioxide and water. Yeah. However, on the incomplete side, we can get carbon monoxide, which is toxic. We can also get carbon particulates, and this is causing global dimming. And then we also get water vapor. So we're getting alternative products, and the products of incomplete combustion are deemed bad. By the way, my laptop seems to have frozen. I don't know why, but it does seem to have just there we go, it's back. Temporarily frozen. Okay, so now that we've kind of identified the two, okay, so the next question is, how do you get this? So how do you ensure, so now that we've got, that's good. By the way, obviously there's a problem here, which is carbon dioxide, which is causing global warming. Global warming, by the way, this is going to tick off one of my learning objectives. And this one here is global dimming. The carbon gets into the atmosphere, the dust gets into the air. Carbon particulates is otherwise known as soot. Yeah, it gets into the air and blocks out the sun. This is what the haze days are, by the way, is that guy. Yeah, this is the haze days. That's haze. Yeah, that's what haze is, carbon particulates. So how do you get complete combustion? Again, pause the video if you think you know the answer. To achieve, I'm going to continue that line down. We're going to need excess oxygen. That's what we need there. And on this side, we have insufficient oxygen. Insufficient oxygen. I like it. So we've got excess oxygen and insufficient oxygen. Okay. Now, the great thing is that pretty much covers all the things that you need to kind of know about combustion before we start putting it into equations. So, and I definitely think at this point, I think that's probably a wise thing to do, really, is to start putting it in, just simply start getting these into equations. So, okay. At this point, guys, equations now start to appear. And the great thing is, once you've kind of got that, it's kind of really easy. Draw. My laptop is now going through major meltdown. And unfortunately, all my tricks haven't helped. So we've got combustion. I can continue anyway. Combustion equations. Okay. So in the combustion equations, I'm just going to give you a series of questions, and then you can have a go at answering them, and then I'll give you the answers. I'm going to make these. I'm going to level these now, folks. I'm going to slowly increase the level. And so then you guys, and then what I'll do is I'll give you some more of these that you can then pick and choose the levels that you like. So question 1, all of these are just right equation. Right equation 4, ... I'm going to make my pen a bit thicker at this point. There we go. Right. Okay, question 1. C3H double it and add 2, 8 plus blank goes to CO2 and water. So the question is, what goes in here? Pause the video, add what it is, and then once you write the equation for /balance, we realize we're going to have to balance all these. It's going to be good practice. So complete the equation and balance, pause the video, have a go at it, which is great. So that's going to be, of course, from our fire triangle, here's our fuel, and now we need oxygen. And of course, oxygen, it's an element that ends in gen. Remember, any elements that end in ene or gen will be in a pair. We know this. Right, now we need to balance it. I'm going to balance this in red, because I can. 3 carbons, 1 carbon. Next, 8 hydrogens, 2 hydrogens, multiplied by 4. Right, oxygens. Here's the tricky one. 6 oxygens because it's 3 times by 2. That 2 goes with the O. And then plus 4. Total number 10. I need 10, so I'm going to add a 5 there, and I'm done. Yay! Winner, winner. We're just balancing equations. So we've got fuel, we've got oxygen. There's our combustion. The next question, which follows immediately on from this, question 2, is this complete or incomplete? Should be very straightforward. Pause the video. And the answer is CO2. As soon as I see carbon dioxide, I know which one it is. The answer is complete. Do you know what I'm suddenly realizing? I'm just gonna... I don't like it. I don't like it. I don't even know if I can do this. Yay, turned it black. And then I can do this one, even though I didn't highlight all of it, and I don't know why. Do that in red. Really, really struggling now. There we go. It is complete combustion. That's awesome. Oh, darn you. There we go. And then it is, I love that I missed the L out. Go figure. Yeah, this is complete combustion because we're seeing carbon dioxide be produced. Complete combustion. Due to CO2 product. Carbon dioxide causes what? Pause the video. Oh, what is global dimming, Dominic? Lara, when black dust blocks the sun, I think. Oh, I see. Thank you. That's absolutely right, Lara. Thanks so much. It's when the black soot, black carbon, because soot is just literally carbon dust, and that dust is black. So it gets up into the air, and it just makes the air black, which means blocks out the sun. Hence called global dimming. So complete or incomplete? It's complete combustion due to CO2 product. What does the CO2 cause? And of course, the answer is, of course, global warming because it's a greenhouse gas. Okay, let's go on to the next question. So question number 3, they're going to steadily get harder. So now we're going to do, let's do C4H blank. Now remember, it's an alkane. So double it and add 2. You can look back at the previous slides on this lesson if you want. So alkane plus O2 goes to CO plus blank. So just pause the video and have a go. So first thing, of course, is CnH2n plus 2. So I need to double it. Takes me to 8. Add 2 gives me 10. Next, right, I'm getting carbon monoxide as a product. What is the other product all the time? And that's water. So, okay, so they're getting steadily harder. We had to recognize that water is always made. If there's hydrogen going in, you're going to get water out. But this time we're not getting carbon dioxide. We're getting toxic carbon monoxide. Now we just need to balance it. So again, pause the video. Have a go. Next, I'm going to do it in red. 4 carbons, 1 carbon, add a 4 in front. 10 hydrogens, 2 hydrogens, add a 5 in front. Oxygens, here's the tricky bit. Right, I've got 4. Oh, that's awkward. 9 oxygens there now, folks. 9 oxygens, which now means I need 4.5 there. You can't leave a half at GCSE, so you double everything. 2, 9, 8. I don't like that line stayed there. Get rid of that. Come on. 8 and 10. And there's your answer. Much harder, that. Nice and easy to see how I'm doing it, though, how I'm staggering it. It was a nice bit of exercise on recapping about the alkanes. And then it was recognition of water always being a product, and then the balancing being much more challenging. Okay, next. Next question. Okay, question number 4. Question 4. Right, this time I'm going to make it smaller. let's go for C blank H6 plus blank goes to carbon and blank. Don't know why I made that one so long. There we go. Right, pause the video. Have a go. My laptop, by the way, is now having a complete meltdown. I am having technical difficulties. It lasted a full hour, and now it's back to it's being just its usual flicky self. But it doesn't matter. I can continue. Right. So again, pause the video. Fill in the blanks. Much more challenging now, folks. So again, I'm constantly kind of increasing the process, although not by much. A very similar process. Yeah. This time I've just excluded 2 people. So number 1, it was CnH2n plus 2 for an alkane. Take away 2, which gives me 4. Divide it by 2 gives me 2. Okay, so there we go. So it was ethane. I'm going to be adding in oxygen. We know that we always need oxygen for combustion. This time it's also incomplete. It's also incomplete. I'm just having a look if I can do anything about my computer. And then I'm also going to get water. You always get water. Now I need to balance it. Again, pause the video. Try and balance. 2 carbons. 2 carbons. 6 hydrogens. Only 2 hydrogens. Need to get a 6 multiplied by 3. Oxygens. Only that one here this time. So we only need 3, which is 1.5. Double it. Can't leave halves at GCSE. So I'm just going to double everything. 2, 3, 4, and 6. And that should add up. I'm going to check that one. So I've got 4 carbons, 12 hydrogens, 6 oxygens, 6 oxygens. It's a winner. Cool. Once again, what environmental problem does carbon cause? Pause the video. Of course, the answer being global dimming. Next, right, let's go for, okay, so now we've had a go at just kind of creating these equations. Yeah, let's continue to make them let's now make them much harder. Now we're going to do what we've been doing, what I need you guys to be practicing, which is the word to symbol. That's much, much more difficult. So we've got butane, incomplete combustion, to produce a toxic gas. Right, so you see the difference. Now they're making you do everything now, folks. Absolutely everything. They're making you realize you've got to transfer butane. You've got to translate butane into a formula first. If you can't do that, you're at a standpoint. That's why I had to do the reminding bit of the year 9 bit from alkanes. So the first thing that's going to happen is butane. So we've got to translate that and recognize it's 4. C4H, double it and add 2, 8, 10. Right, it's incomplete combustion. I need to add oxygen. And I'm going to produce a toxic gas. And what's my other product, folks? Water. We always make water. Right, now we can balance this. 4 carbons, 10 hydrogens, 10 hydrogens, oxygens, 4, 9. So I'm now going to get 4.5, double everything, 2, 9, 8. Have I done this one before? 10. There we go. So there's your final answer. Let's do another one. Question number 6. Right. Write the equation for complete combustion of octane, otherwise known as petrol. Common name, part of the petroleum fraction. Oh, what state is butane in? Oh, what a great question. How do you know there aren't three products? Liquid, question mark? Can there be three products of incomplete combustion? Good question. Oh, okay, so number one, butane has a boiling point of literally 0 degrees Celsius. So at room temperature, butane's a gas. Can you get more than one product? Yes, in reality, you can. They've never asked it. You can, in reality, get a mixture of products depending on the oxygen input. And what I could imagine they could do is give you an equation with everything in it. They're not going to ask you to write one with multiple products because it would be hard to balance it. You wouldn't know which one to add the carbons to. So they've never done it, but in reality, yes, you do end up with a mixture of the products in reality. The only time you only really get no mixture of products is if you have true complete combustion. And that is really when you're looking to get CO2 and water only. Otherwise, you will get a mixture in reality, but we never deal with it in equations because it's tricky to balance. You'd have to measure them all to balance it. Hard. Right. I hope you guys have all had a go at this. So number one, octane. So oct is 8. So C8H, double it and add 2. 16, 18 plus, oh, it's a combustion. So I'm adding oxygen. And it's complete CO2 and H2O only. Right. Gas, liquid. Oh, good. Oh, Tiff. What a great question. You're asking me about state symbols. I love it. In reality, they're all going to be gases because when you have any combustion, the temperature of a yellow flame is 450 degrees Celsius. Water boiled a long time ago. That's why when you see fire, you don't see just it raining liquid water everywhere. Good question. Love it. It's really good, that. So yeah, they're all going to be gases. All gaseous, because of course the temperature of complete combustion, that's like 900 Celsius. At least. It's going to be hotter for the complete combustion of petrol. Blimey, it's going to be in the thousands, folks. Good question. Love it. Next, let's balance it. Right, 8 carbons. Oh, I'm going to balance this with red. I always like balancing in red. It's nice. 8 carbons. 8 carbons. 18 hydrogens, 2. How do we get 18 divided by 2? 9. 9, okay, so 16. 16 oxygens here. 9 oxygens here. It's going to give me 25. 25 oxygens. Divide it by 2, 12.5. Right, double everything. 2, 25, 16, and 18. Done. Done. Winner. And they're going to say, what environmental problem is created by the complete combustion of petrol? And you're going to go, carbon dioxide is a greenhouse gas. Greenhouse gas. It therefore causes global warming. Global whopper. If anybody's ever seen, I've shown you the video of that. Futurama, one of my all-time favorite videos. Global warming from the Futurama perspective. Cool. Right. So let's do another one, folks. Let's do another one. I know it's repetitive, but chemistry is about patterns, folks. I'm going to keep that one on board so you can see it. There you go. I feel like I'm sorry. I'm struggling with my Zoom. There you go. Question number 7. I'm going to make my pen a little bit thicker now. A bit thicker. So I'm going to go right equation. Right equation 4, ... Let's do incomplete combustion of hexane to produce what's wrong with me today? To produce, what do I want to produce? Let's say to produce particulates. Again, scroll back in your notes if you're not sure what they were. What I'd like you to do is have a go at writing it and balance it. Pause the video now. Cool. So, first thing, hexane, C6H, double it and add 2. 12, 14. Next thing, combustion, burning, got to add oxygen. Next, what my products? We've got particulates, which is carbon, plus water, always get water. Next, right, now I need to balance it. 6 carbons, 14, 7. We get 7 oxygens. Oh, 3.5. Double everybody. 2, 7, 12, and 14. We're done. There's my answer. Right. This has been fun, folks. Do you know what? My computer is having an absolute meltdown. So, year 10, what I'm going to ask you to do is I have corrected the post on the classroom. I think my laptop needs to have a bit of a chill because it's kind of lost the plot. What I've done is on the classroom, I've amended it. I thought I'd posted it for both. I had posted for both classes, but one of them I hadn't. For yours, I hadn't linked in the sheet, and I'm so sorry. So I've linked this into the sheet, into your Google Classroom. Have a go at this for your homework. I will add a few more on combustion specifically today. Have a go, mark them. By the way, the answer sheet I will also post. In fact, yeah, I'll post the answer to this on the classroom as well. I'll post that in about an hour or two, so it's there for you guys to check. Cool, so what I'm now going to do, I'm going to actually end my lesson slightly earlier since I'm having technical difficulties. My laptop is having a complete meltdown, which is a nightmare. I'm just going to have to full on turn it off before I start my next lesson. I'm going to turn back on. Oh, technical difficulties. Turn that back on. Go back to here. There we go. Do start cam. I'm going to do that one, start camera, and it should bring me back. Go on. Is it going to be there? Oh, that's the back camera. I don't want the back camera. I don't know what that is. I have no... oh, camera and mic settings. I can fix this. Sorry about this, folks. Oh, my laptop's taking ages to do anything. It's really struggling. Front camera. There we go. I'm back. I'm back. Woo, we're here. Right, guys, I'm going to leave you be now. As I said, my laptop's really struggling. So I hope you guys are keeping safe and staying well. Have a go at the questions on the sheet. I hope yes, absolutely. Lesson as normal tomorrow. Have a great rest of your day, folks. It's been good to see you all. Take care of yourselves. Bye now.